Okay, so, sorry I have to be out today, but we're gonna continue on, and then you can work on the homework worksheet. So today we're gonna be looking at, let me make this a little better. Today we're gonna be looking at the difference in standard deviation, and how to use that as a test statistic in hypothesis tests. Okay, so this says Mike is a member of his high school golf team. He's considering buying a new club, hoping it will make his shots more consistent. So to investigate, Mike decides to conduct an experiment. He will use his current club and borrow a teammate's club to see which of the two makes the distance he hits more predictable. So again, it's this idea of being predictable that is probably the most important. So we are going to identify the treatments. The treatments in the experiment are going to be the two different things we're comparing. So in this case, it would be his current club versus the new club, okay, or his teammates' club, okay. The explanatory variable then would be the type of club that is being used. And the response variable in this case, we're looking to see if it's about the distance to be predictable. So in this case, it's going to be something that we can measure. In the past, our response variable has been like a success or a failure. But in this case, we're actually able to measure the distance. So let's make that our response variable, that it will be the distance the ball is hit. Okay? Another little review. Is it possible for Mike to be blind in this experiment? Remember, blind does not mean that they can't see. It means that they don't know the difference between the treatments. So I would say if he's using his club and someone else's, even if they were similar, he might be able to tell which one is his. So I'll say for this, probably not. Because Mike will be able to tell which club is his. Okay? If you said yes, if they looked similar enough, that's fine. You just want to justify the response. Just remember that to be blind, this is irritating, sorry. To be blind, he would not know which treatment he got. So that's something that some of us struggled with before the idea of being blind. And so to be blind would mean that he wouldn't be able to tell if the club he was using was his or his teammates. And since he's probably used to his club and what it looks like and all of the intricate details about it, that's why I would think he probably wouldn't be able to be blind. So we're looking at being predictable or consistent, and a summary statistic that we can use to measure consistency is standard deviation. And so for the experiment, because we're comparing two different clubs and the distance that the ball travels with each one, we could use the difference in standard deviation as a test statistic. And we'll use the current minus the new to see the difference. Because again, he thinks that the new club is going to be more consistent. So the current one will probably have a bigger standard deviation because it's worse. Well, we don't know. Anyway, so it's important to remember that when we perform the experiment, we're looking at Mike's performances with the different clubs. When we calculate the standard deviation, we're going to be finding the observed standard deviation as opposed to the true standard deviation. The observed standard deviation, you guys, is an estimate of the standard deviation based on an actual set of performances. So the observed standard deviation is something that we calculate. And that's what we will be calculating with this data. That's different from the true standard deviation because the true standard deviation is the standard deviation after an infinite number of attempts all under the same conditions. So because it's after an infinite number of attempts, notice that the true standard deviation exists only in theory, and it's not something that we're ever going to be able to find. What does this definition sound an awful lot like? Doesn't it sound an awful lot like ability? And that's what we want to remember about the true standard deviation. The true standard deviation, like the ability, is something that exists only in theory. It would be what the standard deviation would be if we were able to calculate an infinite number of performances, but we can't do that, okay? So the experiment was conducted, and this table summarizes the results. So let's use the results of the experiment to find the test statistic that we described. And the test statistic that we were going to use was this difference in standard deviation. So we should calculate the standard deviation of each of these sets. Remember that you can find the standard deviation by going to your calculator and putting the values in the lists. So I'll put the values for the current club in list 1. Oops. Okay. And I'll put the new club in list 2. And then remember, we go to stat calc in our one variable stats. First I'll do L1. And I see that the current standard deviation is 13.56. So I'll make a little note here that my current standard deviation is about 13.56. Then I can do the one variable stats, clear it out, for L2. And I see that the standard deviation for the new is 7.72. So the new standard deviation is about 7.72. So to find our test statistic, we are going to use the difference in standard deviation current minus new. And so we can take 13.56 minus 7.72, and we get that that difference is going to be about 5.84. Oh, and this is measured in yards, sorry. So this is our test statistic that we'll be using. So we have a difference in standard deviation of about 5.84 yards. And so what we would want to do is see how likely this is to occur just by random chance. So what we would do is use a simulation. And so here's a simulation of those differences. And so we want to run a hypothesis test. to see how likely it is that this 5.84 occurs. So here's the thing. Instead of talking about the ability to be consistent in our hypotheses, what we're going to do is reference the true standard deviation. So this is huge. In the past, all of our hypotheses have always said ability. But now what we're going to do is we're going to use this idea of true standard deviation. So this is what we're going to use in our HO and in our HA. Because that true standard deviation, we said, was like the ability. So this idea of this true standard deviation, because it is like ability, we're able to use this verbiage in our hypotheses. So here's how our hypotheses would look here. Our null hypothesis would be that Mike's true standard deviation are the same with the new club and the current club. So I know that we're not using ability, but the idea of the true standard deviation is something that would be calculated with an infinite number of times, like ability. And we're saying that if we have no bias, like we do in our null hypothesis, that the true standard deviations should be the same. That's what we're going to assume. But we want to see if this new club is a lot better. And so remember that that means that that the standard deviation would be smaller. We found that the observed standard deviation was smaller, so we're going to hypothesize about the true standard deviation. So we can say that Mike's true standard deviation, which is like ability, is smaller. Oops. With the new club than with the current club. So notice that in the past we've always had to talk about ability, but here we're going to use true standard deviation as our measure, okay? Our test statistic was the observed standard deviation. So this is an observed standard deviation that we were using for our test statistic, but we're going to hypothesize about the true standard deviation. So I'd like you to use that in our HO and HA. That's what the homework key will look like tomorrow. So now that we have our hypotheses and we already found our test statistic, we have the simulation that use the same type of a thing. We'll talk about simulations in the next lesson. But we want to see how likely it was to get our test statistic. Well, remember, our test statistic was that difference of standard deviations, and our test statistic was 5.84. So there was a difference of 5.84 yards. We want to see how special that is. So anything greater than that also would be special. So we're going to count how often that the simulation gave us values at or above 5.84. So let's look at our scale. So here's 4, here's 6. So that means that this is 5. This would be 5.5. So 5.84 would probably be here just below 6. And so I want to include all of these values. And so I see that I have 1, 2, 3 values out of the 100 trials. So I have 3 values at or above 5.84 over 100 trials. So that gives me a p-value of 0.03. So again, to interpret the p-value, what that means is that we would want to talk about, remember, we discuss our test statistic and random chance. And our test statistic has a name, the difference in standard deviation, and it has a value, 5.84. So we can say there is a 3% chance of getting this test statistic, which was of getting a difference in standard deviation and again we did current minus new. We were looking for a difference in standard deviation of at least 5.84. Just by random chance. So again, our p-value looks interpretation of the p-value looks very similar to what we had done before. We talk about our test statistic, which was the difference in standard deviation, current minus new. We give the value of our test statistic, 5.84 yards, and we talk about random chance. So there's a 3% chance of getting a difference in standard deviation, current minus new, of at least 5.84 yards just by random chance. And remember our conclusion, we always talk about, we mention our p-value, our significance level, and our alternate hypothesis. And so we can say, just as we would have in the past, that since our p-value of 0.03 is less than 0.05, that means that we do have convincing evidence that Mike's true standard deviation is smaller with the new club than with his current club. Okay? And so notice that in our conclusion, we also talked about the true standard deviation, which again was like ability as far as that's concerned, because it's something that would happen if we were able to do something an infinite number of times in similar conditions. So that's the scoop. So the biggest differences are the idea that in our hypotheses involving standard deviation, let's use true standard deviation in our HO and our HA. Notice in the HA, it's better to have a smaller true standard deviation. So whatever one you want to quote unquote win, you want that to be the smaller true standard deviation. And again, we don't know if this is true. This is just a simulation. And so we're just hypothesizing about this true standard deviation. But it looks like we have evidence that Mike's true standard deviation is smaller with the new than with the current. I guess that's it. So you guys can work on the worksheets the rest of the time, and that's it. Thank you. Be good.